Welcome to video 1, how to find the number of valence electrons. Now, technically, everything in this video is old news. There's nothing actually new, minus one piece of information that is also going to be covered in a later video. This is just to make sure that we're all on the same page. So we're talking about the number of valence electrons. Well, this should already be written at the top of your periodic table. If it is not, please add it. Make life easy for yourself. Everything in the first column has one valence electron. Everything in the second has 2. We skip the middle. Everything in the third has 3, and so on down to the last column, called the noble gases, which have 8 valence electrons. This is it. If you ever need to know how many valence electrons something has, you find out by looking at the periodic table. Which column is it in? That's it. That's how you figure it out. But let's review a little bit about what a valence electron is, just to make sure that we understand why that might matter. So check out this Bohr diagram on the right. You can see this is for sodium. I got 2 electrons in the first shell, which is how many it can hold. We got 8 in the second shell, the maximum there. And then we got an 11th electron hanging out in that third shell. It's the only one in that last shell. That last shell is called a valence shell, and the 1 electron in it is called a valence electron. So sodium has 1 valence electron. And if we go back to here, you can see that sodium, Na, is in the first column, which has a 1 written on the top of it, telling me it has 1 valence electron. Yeah, it all works out. Let me just move the face for a sec. Keep in mind, though, that atoms want 8 valence electrons. They don't want 1 or 2 or 3 or 4 or 5 or 6 or 7. They want 8. They want 8. 8 valence electrons is what makes them stable, non-reactive, low energy. And that's the goal. They want to be lazy. So they will do whatever they can to get to that 8 valence electrons. Now, there are 2 ways that it can do this. The way we've been learning about so far this semester is, well, they can become an ion. They can gain valence electrons to get to 8, which gives them an electric charge. Or they can lose their valence electrons to get to 0, which is the next best thing, which also gives it an electric charge. And this happens when 2 atoms bump into each other, and their electronegativities are very, very different. All right, that's the new piece of information, but don't worry too much about it. We'll come back to it later. All you need to know is that when this atom has low electronegativity, but this atom has high electronegativity, and they bump, an electron is going to jump ship, and they're both going to become ions. Now, the other thing they could do is they could share instead. I spoke about that very, very briefly before the break, I believe. And again, don't worry too much about that. We'll learn about that more later. And that only happens when their electronegativities are very, very close together, when they're almost the same. All right, but what's electronegativity? So this is a blast from the past from Unit 2. We did learn about electronegativity. It is how much it wants 1 more electron. That's it. So if you got 2 atoms that really want 1 more electron, they're going to share. But if you got 1 atom that really wants an electron, and 1 atom that doesn't really care, they're going to become ions instead. There's going to be stealing going on. All right, but we're not going to be looking up the numbers. Our shortcut is this. Write this down, although it will be in a later video. If you have a metal and a non-metal bonding, it's going to be ionic. It's going to be an ionic bond, exactly like what we've been doing so far. But, new stuff, if it is a non-metal and a non-metal, their electronegativities are going to be very close. And they will instead share, or bond covalently. More on that, not today. All right, so here we have our periodic table again. That first column has 1 valence electron. It's going to lose it to become a +1 ion. The 6th column is going to gain 2 more to get to 8, becoming a -2 ion, and so on. And again, all of this should already be on your periodic table of the elements. Here's what it comes down to. You look at the periodic table, it tells you how many valence electrons it has, and it tells you what the ionic charge will be if it becomes an ion. All right, quick check for understanding, and then we're done. How many valence electrons does each neutral atom have? On your periodic table, find hydrogen, find carbon, find fluorine, find nitrogen, find oxygen. How many valence electrons do they have? Please press pause until you find the answer. I am now assuming you have found the answer. How'd you do? All right. If you have any questions, shoot me an email or talk to me in class. You've survived video 1.